Okay, hi 13 doubles. So this is the second way of doing it. This is the way the book does it, and yeah, it's a nice method because if you look at it straight away, you probably realise this is wonky. It looks like it's been rotated 45 degrees. So if we can just rotate it 45 degrees, I guess if we rotate it, because we're normally used to dealing with these on this axis here, yeah, if we can just rotate everything 45 degrees, yeah, so that it's back on the focus being on the x-axis and the directrix being the line x equals minus a, just so it's in that typical position, then we can use our ideas like y squared is 4ax, but also the general parametric point on the curve is x equals at squared and y equals 2at. We can use those ideas then, yeah? So let's just find where A would end up if I rotated it 45 degrees. And this will be helpful because this will remind us how we use matrix multiplication to rotate something 45 degrees. Now, personally, what I do for these ones, I don't look it up in the formula book because I just think if I want to rotate 2 points 45 degrees, remembering that I deal with this column vector first, 1, 0, and this column vector second, 0, 1, I just think about where they end up. Yeah, so if I want to rotate 45 degrees clockwise, for example, yeah, I'm going to rotate this 45 degrees clockwise because I want to rotate A 45 degrees clockwise just to find out where it ends up on the x-axis. Well, if I want to do that, I just think about where these 2 points end up. So 1, 0 is clearly going to end up at 1 over root 2 and minus 1 over root 2. I hope you don't mind me just assuming that it's obvious that that's going to be 1 over root 2 there, just because that line's going to be 1, and so you're dealing with 1 over root 2 and 1 over root 2. It's like SOHCAHTOA trigonometry. And the second point is going to end up at 1 over root 2, 1 over root 2, but it's all going to be positive. So that matrix is going to rotate things 45 degrees for me. So now if I multiply that, I'm not drawing this out very neatly, but if I multiply that by the point 2, 2, I'll work out where it is on the x-axis, where the focus was basically initially, and then I know the value of A, and then I can rotate it back round in the other direction to find what the general point is. Okay, when we multiply this out, we're going to get 2 over root 2 plus 2 over root 2, and that's going to be 4 over root 2, and 4 over root 2 is 2 root 2. When we do it the other way, that one times that one plus that one times that one, we're going to end up with 0. And so I can immediately see that A would end up at the point 2 root 2, and hence, if you're dealing with y squared equals 4ax, then A equals 2 root 2. Yeah? So what are we going to have to do now? We're going to have to take the general point, and the general point on a parabola is given by x equals at squared, y equals 2at. So we're going to have 2 root 2 t squared, and then so it's at squared and 2at, and then 4 root 2 t. That's going to be our general point on our parabola, and we're going to try and rotate that now back up 45 degrees anti-clockwise. Essentially what I've found, let me make this a bit clearer, I might even show you a little bit of GeoGebra here, but what I've found is if you think about the parabola before it was rotated 45 degrees, it would have been like this, yeah? What I've found is the general point on that parabola, yeah, and I'm now going to rotate it back 45 degrees in the other direction. That's the way I'm thinking about doing it anyway. I'm not sure exactly what the book did in the back, but that's how I'm thinking about it. Okay, so all I need to do now is rotate this 45 degrees anti-clockwise. Well, let's just quickly figure out the 45 degree anti-clockwise matrix. That's going to make that one go down there and this one go up here. It's going to be very similar to before. So what we're going to have is 1 over root 2, 1 over root 2, but then that's going to be minus 1 over root 2, 1 over root 2. And that's your 45 degree anti-clockwise rotation matrix. So what am I going to do with that? I'm going to multiply it by the general point on the original parabola, which has already been, I describe it as the original parabola, but I mean the parabola after I rotated it 45 degrees. That's the general point on that parabola. Now I want to rotate it 45 degrees again, and then I can eliminate the parameter t and work out the Cartesian equation. I don't think it's necessarily easier or harder than my method. It's about the same, I suppose. But see what you think. It's very much personal taste, this kind of stuff. I tell you what, though, there's loads of questions where a rotation using a matrix is actually a really cunning plan. So bear that in mind. This is not this is a lovely skill. It would always be regarded as a difficult question, but it is a good skill. Okay, if I do that one times that one minus that one times that one, what am I going to end up with? Let's have a look. The root 2's are going to cancel out, so I'm going to end up with 2t squared minus 4t. And that's the x component. Here, I'm going to end up with 2t squared plus 4t. Oh, lovely. Okay, so this looks quite nice. So I start getting excited here because I'm getting near to the end. So x equals 2t squared minus 4t, and y equals 2t squared plus 4t. And all I'm going to do now is try and eliminate the parameter. Well, they're quite good fun, these ones, to eliminate parameters. I suggest adding them is 4t squared. Subtracting them is 8t. Now, to eliminate this, why don't we just show, because we've got to show that this result is true, x plus y is 1/16 x minus y squared, why don't we just point out that x minus y squared is therefore 64t squared, and x minus y squared over 16 is 4t squared. Oh, so x plus y, or can we put an alas in here? This feels like the moment where you really need the word alas. Alas, x plus y equals x minus y squared over 16. Okay, hopefully that was good. I hope you enjoyed that. I quite enjoyed that question. I love conics. They're great fun. There's so many different ways of doing exactly the same thing, and there's just some really fun approaches, and it gets your coordinate geometry rock solid. It really does. Okay, so hope you enjoyed that, and I'll speak to you on Thursday. Bye bye.